I wouldn't be the first to say that Ramanujan is one of the greatest mathematicians. But when you follow his work, you begin to realize that some of his discoveries are a little bit strange. And today, I'm going to be showing you and explaining 3 of his greatest discoveries of all time. But history matters too, so I'll keep this quick. In 1887, Ramanujan was born in what is now Erode, India, where he almost entirely self-taught himself. In 1913, he wrote a letter to English mathematician G.H. Hardy, and Hardy was so stunned by his work that he invited Ramanujan to work with him in Cambridge University, specifically Trinity College. And sadly, Ramanujan died early at the age of 32 in 1920 to what we now know as hepatic amoebiasis, but was misdiagnosed at the time as tuberculosis. The first one is the Ramanujan summation, which basically says that the sum of all positive integers, meaning 1 plus 2 plus 3, going all the way to infinity, is negative 1/12. Now, it's not a literal sum, you need to understand that, because in regular mathematics, this sum would 100% diverge to infinity. However, Ramanujan made something called the Ramanujan summation, which basically allows you to assign meaningful values to typically divergent sums. Now, I'm not going to go into too much detail because I already made a video about this, but basically by manipulating a few series, we can deduct that the sum of all positive integers is negative 1/12, which is crazy. Now this next one is chaos. It's integer partitions, and a partition is basically how many times can a number be broken into smaller numbers. For example, the partitions of 6 are 11, because the number 6 can be broken into 11 different times. So 3 plus 3, 2 plus 2 plus 2, etc. And Ramanujan wanted to figure out, is there a formula that will tell us how many partitions a number has, just by plugging it in? By the way, this is much easier to visualize with shapes, so take a look at some of those I've put on the screen. And the formula is, say it with me now, P of n is approximately equal to 1 over 4n root 3 times e to the pi root 2n over 3, where n is the number you want to know the partitions for, P of n is what you plug into, and the exponent explains why this blows up so quickly. By the way, Ramanujan is iconic for adding tons of what seem to be random terms in his work, and you can really tell this is Ramanujan's formula. Now this last one is one of my personal favorites, and it's Ramanujan's series for pi, which goes, say it with me one more time, 1 over pi equals 2 root 2 over 9,801 times the discrete sum going from k equals 0 to infinity of 4k factorial times 1,103 plus 26,390k over k factorial to the 4th times 396 to the 4k. Now this impressed people not just because it looks really cool and crazy, but also because each term added dramatically improves the accuracy it has to pi, and already at 3 terms, you're overkilling, which is insane. So, Ramanujan died in 1920 and only at the age of 32. However, his formulae were so powerful that mathematicians are still finding things hidden inside of them. And fun fact, Ramanujan often used to not use proofs to build his arguments, and he'd say that his discoveries came to him in his dreams. However, they all still work, and that's what makes Ramanujan one of the legends of mathematics.